Hi, welcome to the video solution for physics past paper solution. This is Cambridge IGCSE Physics, May June 2021, paper code 0625, paper 22, and this is the second video of the series. So let's start. Question number 21, a water wave passes into a region where the wave travels more slowly. As it passes into a slow region, what happens to frequency and what happens to the wavelength of the wave? So it's all about wave is passing from one region to another, and this statement of more slowly suggests that the wave is passing from deep to shallow water. Remember, in shallow water, in shallow region, speed of the wave decreases. So I'm giving you a table summarizing all the behavior or the property of the wave, and if you can note, if you note it down, I would recommend. It will give you a lot of help to give answer of such question. So this is the table. If you note it down, this will be good. This is the water wave behavior from deep to shallow and from shallow to deep. So from deep to shallow, speed of the wave decreases and wavelength also decreases. Frequency stays the same while wave moves towards the normal. While if you write shallow to deep, so everything is vice versa, except frequency always remains the same regardless the region. So of course frequency stays the same, so you can ignore A and B immediately. It does not increase or decrease. Frequency always remains the same. So C and D both are correct. And what about the wavelength from slow region or from in shallow region? So wavelength is decreased. So option is C. Question number 22. Light traveling at a speed of 3 × 10⁸ meter per second strikes the surface of a glass block and undergoes refraction as it enters the block. The diagram shows a ray of this light before and after it enters the block. So we have a ray of light entering into glass block. This is angle I, this is angle R. What is the speed of the light in the glass? We need to find speed inside the glass. So here we have a speed of light in air. This is air. And generally speed of light in air is denoted by C. With this C is this number, speed of light. And speed of light in glass block is denoted by V, and we are giving incident and refracted angle. So remember, the idea is the refractive index of glass N is equal to, in terms of angle, is sine I over sine R. This is the refractive index of a glass block in terms of angle. And in terms of speed, refractive index N is C upon V. So refractive index of glass is C upon V. Now, because we need to find speed, so we can combine these two equations and we can say that C upon V is equal to sine I divided by sine R. And now we need to find the velocity in the glass block V, so we need to make V as a subject. You use your mathematics, do cross multiplication or whatever suits you when you make V as a subject. So V would be equal to C times sine R divided by sine I. That means if you do 3 × 10⁸ times sine of 33 divided by sine of I, sine of 55, V would be equal to 1.99 × 10⁸, and you can round it off 1.99 as 2. So 2 × 10⁸ meter per second. So option is B. Question number 23. Which statement about the image of an object formed in a plane mirror is correct? Remember, it again a typical question of plane mirror image. Plane mirror. This is same size, virtual, at same distance. Inside the mirror, within the mirror, or from the mirror inside. So which statement is correct? It is a smaller than object. No. It is larger than object. C, it is wrong. It is inverted. Plane mirror image is never inverted. It is erect or same as the object. So it is same size as that of the object. So option is B. An object is placed in front of a thin converging lens. The diagram shows the path of two rays from the top of the object. This is the object. Thin converging lens rays are coming, passing from the lens. An image of the object is formed on the screen to the right side of the lens. How does this image compare with the object? So first of all, the image is formed to the other side of the lens. One side is object, image is formed to the other side. So image will always be real. Real image and inverted. So if image is formed other side of the lens compared to the object, we always have inverted image. And the size of the object depends on the distance of the image and distance of the object. Now if you see, this is the distance of the object given in the diagram, and if you keep extending the wave, the rays, clearly you see that the waves are going to intersect somewhere which is comparatively a larger distance from the lens as compared to the object distance. So this distance is large. That means this image will be greater or larger image. So it is a larger and inverted image. So option of 24 is A. If image is closer compared to the object distance, then it will be smaller image. Question number 25. Here are three statements about the speed of electromagnetic waves. The speed of electromagnetic waves in a vacuum is 340. Now, this is the speed of sound. This is a wrong statement. The speed of an electromagnetic wave in a vacuum is 3, which is true. The speed of an electromagnetic wave in a vacuum is approximately the same as in air. So, yes, we consider that speed of electromagnetic radiation, electromagnetic waves in vacuum and in air is approximately same. Which statement is correct? 1 and 3. 1 is absolutely wrong. 1 is wrong. 2 only. No, 2 and 3 are correct. So option is C. The sound from a loudspeaker must pass through two material to reach the microphone. So the sound waves are traveling these two material reaching the microphone. Which combination of material gives the shortest time for the sound to reach the microphone? So shortest time mean wave must be moving faster. So speed must be large enough. And it is all about sound waves. So sound travels fastest in solids. So both material must be solid. So air and hydrogen, no. Air and water, no. Copper and aluminum, yes. Fourth, water and oil, of course, no. So option is C, because both are solid material. Which method does not demagnetize a bar magnet? Heat the bar magnet and place it east and west. Yes, it will demagnetize. So this is correct. We need to find which does not demagnetize. So it will demagnetize. Place the bar and hammer it. So hammering, heating, causing demagnetization. Place the bar magnet in a coil connected to AC supply and slowly withdraw. Yes. Withdraw a magnet from a coil passing AC electricity. So in all the three ABC, both are correct. And the magnet will demagnetize. But if you place the bar magnet in a coil and the DC current slowly withdraw, so DC current will not demagnetize. So the option is D. Question number 28. 3 piles of small nails PQR are placed on a bench below 3 electromagnets. One set of nails is made of copper, one of soft iron, and one of steel. Diagram 1 shows the situation when the electromagnets are switched on. Diagram 2 shows when the electromagnets are switched off. So this is diagram 1. Switch is closed. That means all are electromagnet and attracting. So these are nail P and nail Q and nail R. So nail P does not attract. P and Q and R both are attracted because circuit is on. So this is electromagnetic working. Switch is open. Turn off the switch. So electromagnet, they are not electromagnet anymore. They are not magnet anymore. So P remains at the bottom, of course. Q falls down. R is still intact. Now, which row correctly identify the material of each nail or nail are made of? So, of course, nail P are not attracted. And it's, of course, this is copper. So, option is P and P. Both are copper. Q cannot be copper. So, C and D are immediately gone. Don't waste your time. You need to figure out A and B. The idea is, if you turn off the switch or you open the switch, then that means nails R is still intact with the rod. The reason is steel. Steel is a material which after magnetization, it takes some time for demagnetization. So it remains magnet for a longer time. Even after open the switch, nails R remains magnet for some more extra time or some extra time. That's why they remains intact even after opening the switch. So R is made of a steel, and Q immediately lose their magnetism. That's why immediately they fall. So they are made of iron. So Q is iron and R is made of a steel. So option is A. Question number 29. A magnet is suspended by cotton thread. The magnet is displaced, then allowed to swing freely until it comes to rest. A typical behavior of a bar magnet or any magnet, when you disturb a magnet hanging with a cotton thread, it always comes to rest. The reason is the magnet is interacting with the magnetic field of the earth. So because the interaction of there is nothing to do with the electric field and the magnet or electric field, there is no electric field, so A and B are immediately gone. Because the interaction of the magnetic field between the magnetic field of the magnet and no, there is nothing to do with the gravitational field. Yes, this is because interaction of magnetic field of the magnet and magnetic field of the earth. So option is D. A student rubs a plastic rod with a cloth. The rod becomes positively charged. What happens to the rod? So you had a rod before which was on neutral. When you rub with the cloth, after rubbing, then the rod becomes positively charged. That's what they are saying. And the reason is due to rubbing, electron from the rod transferred to the cloth. So the rod has lost electron. It has lost electron. Remember, proton does not gain or does not lose. So B and D are absolutely wrong. Proton does not move or gain or lost. This is electron. So electrons lost, that's why we have a positive charge. So option is C. 31. An isolated metal sphere is positively charged. It is then brought near to another isolated metal sphere that is neutral. So this is a neutral sphere, isolated, and another positively charged sphere is coming closer, not touching. What happens to the charges on the neutral sphere as the positively charged sphere is brought close to it? So what happened? You see that so as the this metal sphere come closer like this, that means it starts attracting electron of the neutral metal, and because electrons are freely moving particles, so electron start attracting and start gathering at this end. So electron moves left. But remember, positive charge do not positive charges, which are basically proton in the nucleus, they do not move. So they remains uniformly spread and they do not move. Only negative charges move. So some positive charge move, positive charge don't move. Some positive charge move, no. The positive charge do not move. Some negative charge move to the left. So negative charges, which are electron, free electron, moving electron, they move to the left, but positive charge don't move. So option is D. (32) Which circuit has a 0 reading on the ammeter? So okay, we have a diode in this each circuit. So we need to see which circuit has a 0. That means current is not passing. So you need to see that whether the diode is connecting in a correct direction, correct order. That means whether it is a forward bias or a reverse bias. So diagram A, you see this is the negative terminal of the diode and this is positive terminal of the diode. And negative terminal is directly connected with negative terminal of the battery, and positive is through the resistor connecting positive. So positive with the positive, negative with the negative, the diode is in forward bias. So it will allow current. So we have some current in the ammeter. Diagram B, we have negative terminal connecting with the negative terminal. So again we have a forward bias. So the current will flow through the circuit. In C, we have two diodes. The first diode, negative terminal with the negative terminal, and the second diode, this is the positive terminal connecting with the positive terminal. So of course, again, circuit C, both diodes are in forward bias. It will allow current to pass through the diode. So we have a current in the ammeter. But diagram C, this diode on the left side, positive terminal of the diode, positive terminal of the battery. So this is in a forward bias. It is fine. It will allow current from the diode. But the second diode, positive terminal connecting with negative. So this diode is in a reverse bias. And reverse bias does not allow current from passing through the diode. So it will not allow current. So there will be no current in this circuit, and the current in the ampere meter will be 0. So the circuit is D. 33. Two 10 ohm resistors are connected in series and then in parallel. What is the combined resistance in each case? So in series, we just add resistors together. We have two 10 ohm resistors, so 10 plus 10, 20. So we cannot have a 10-10 option. So we have both correct, C and D, 20 ohm resistor. Now let's go to the next column, parallel combination. Two equal resistor in parallel. So the combined resistance is half of the combined one. So half of the 10, which is 5. This is always situation. If you have a two equal resistors in parallel, then combined resistance will be half of the resistor. So it will be 5. So option is C. Meaning if you instead of 10, if you take, it's just an example. If you take 4 ohm and 4 ohm parallel. So the combined resistance of parallel to 4 ohm resistor will be 2 ohm. Half of that. So option is C. Okay. Question number 34. The diagram shows a combination of 4 logic gates that produce an output signal at R that depends on the states of the input P and Q. So we have some combination of logic gate. This is NOT gate. This is AND that you need to remember. And this is again a NOT gate. So for these types of question, initially, if you don't have habit to mentally doing that, so it is a good idea to make a truth table of each step. It takes time, but that's what you can find easy answer. So which single logic gate produce the same effect as the combination? So AND gate or NAND gate or NOR or OR. Remember, if you figure out the truth table of AND gate, so truth table of AND gate is this. So if any one is 0, the output will be 0. AND gate will gives only 1 if both gates are 1. Both inputs are 1. So, and NOT gate always gives your opposite. If you have a, for NOT gate, if you gives input 1, output will be 0. If you give 0, output will be 1. That's the behavior of NOT gate. So let's make the table of this overall logic gate. So I will be giving you blank table P and Q R. Now clearly P, Q, R. So you can do one by one. If P0, Q0, 0 and 0. So of course output will be 1 and 1 because this is NOT gate. And if both are 1, output will be 1. So here it will be 1. AND gate 1. And then NOT gate will give you 0. So this is 0. So final R will be 0. And if instead of P0 but our Q is 1, now make it 1. If it is 1, then of course it will be 0. And if AND gate input anyone is 0, this is 0 and it will be 1. So you have R1. Now if you do P1 and this 0, so this is 1, but this is 0, so this is 0, and 0 gives you 1. And anyone is 0, the output will be 0, so it will be 1, so this is 1. And if both are 1, P and Q, this is 1 and this is 1, then both output of NOT gate will be 0 and 0. If AND gate is 0, this is 0, then again output will be 1. And if you see, this is the final output, 0, 1, 1, 1, and this is the output of OR gate. You can see your table, truth table of OR gate, 0, 1, 1, 1. And that means instead of all these combinations, we can use only one logic gate, which is the OR gate. So option is D. Question number 35. A solenoid is connected to a very sensitive ammeter. A rod is inserted into one end of the solenoid. The ammeter shows that there is a small electric current in the solenoid while the rod is moving. So when you inserted a rod into the inside the coil, we see the current. It's all about that means we have electromagnetic induction, moving rod into the coil, and EMF is produced, current is produced. So which rod is being inserted? A heated copper, there's nothing to do with the heat and production of current. In this case, magnetized steel rod, yes, that means this rod is magnetized, meaning it is a magnet, and magnet moving closer to the coil, changing the magnetic flux, causing EMF to induce. So option must be B. But let's see the option C. An uncharged nylon rod, nothing to do with the uncharged, and nylon rod will not produce that effect. Radioactive uranium, nothing to do with the current and EMF. So option is B. 36. The diagram shows a transformer. So we have what is the output voltage? This is VP. Primary voltage. This is NP, number of primary turn. This is NS. And this is output voltage VS. So we need to find VS. So equation is VS upon V1. Ratio between the voltages is same as ratio between the number of turn, NS upon NP. You can flip the whole formula. It's your choice. But because we need to find Vs, that's why I wrote Vs upon Vp. Make Vs as a subject. So Vs is equal to Ns Vp divided by Np. Substitute the number. Ns, number of second return, 115 times Vp, 22,000 divided by Np, 550. So Vs would be equal to 4600 volt. Option is C. Question number 37. Which row correctly states how nuclei behaves during nuclear fission and nuclear fission? Fission is the splitting of a large nucleus. Fusion is combining or fusing two lighter nuclei. So in fission, splitting occurs, so not joining, nuclei splits apart, both are correct. And in fusion, nuclei join together, this is correct, this is wrong, option is C. 38. The charge on a proton is E. What is the charge on an electron and what is the charge on a neutron? Of course, charge on electron is opposite to the proton. If charge on a proton is E, charge on an electron will be minus E, and charge neutron is 0, neutral. So you have electron column, it should be minus E, and neutron charge is 0, option is D. Question 39. Some radioactive nuclei decay to give new nuclei which are also radioactive. Part of series of decays is shown. So uranium decaying into thorium, thorium then palladium, and then uranium, and then thorium, and then radium. So we have a series of decaying process. How many decays involve the emission of beta particle? Remember, emission of beta particle, mass number, or you can say nucleon number. Nucleon number does not change during beta decay. So you need to find which step is keeping mass number same. So first step, 232 to 34. No, it is not a beta. This is in fact alpha. 234 to 234, mass number same. This is the one, correct one. 234 to 234, again beta. This is correct one. And then 234 to 230, no. And then 230 to 226, no. So we have only two steps in which beta particles are emitted. So there are two decay which involves beta emission, option B. Question number 40. The graph shows the activity of the radioactive source over a period of time. So we have activity over time in minutes. What is the half-life of the source? Simple, straightforward, easy 1 mark question. Decay graph is given. Initial activity is 120. We need to find half-life. Half of 120 is 60. And corresponding time of 60 is 2 minutes. So 2 minutes is the half-life. Option is B. Thank you very much. I hope you understand. If you have any doubt, let me know in the comment section. I will try to give you an answer and try to clear your doubt as soon as possible. Have a nice time.